So to begin with, let's take a look at digit manipulation in iOS. And I believe we went over this in one of the previous deep dives. I believe it was most likely either, in fact, I'm pretty certain that it was deep dive module 10 when we were talking about globalization and localization in the big call manager, CUCM. And we talked about it in regards to iOS gateways. I don't believe we had an animation slide on it. Instead, I believe we whiteboarded it. I've since gone ahead and created an animation slide to help you understand and have a reference material later to go back and look at this slide to see the order of operations and how and where digit manipulation can take place inside of really any iOS router. And the only reason that we're doing it again is because with CME we have a couple of special places that we can do it. It's really, if you watched the last deep dive module 15 and the basics of skinny and SIP phones in CME, then you know that from the nice animation slides that we had there, you know that skinny phones are really, when we create ePhones and ePhone DNs, what we are really creating are POTS dial peers. And if you didn't watch 15, that might be a bit of a shock. You might say, wait a minute, it's an IP phone, Mark. It's not a POTS dial peer. Well, it actually is. It's a POTS dial peer. It's a FXS, but it's actually an eFXS port, an electronic or virtual FXS port. And the ePhone DN creates the actual port. So the ePhone DN creates a voice port, an eFXS voice port, although it's virtual and electronic and doesn't show up in command line. And the ePhone itself combined with the ePhone DN, so once we apply the button to the ePhone, then we create the POTS dial peer that points to the previously created eFXS voice port. And we also know from SIP phones, so voice register pool and voice register DN, the combination of those two, so creating a voice register DN, a SIP DN, and then a voice register pool and applying that voice register DN with the command button, or number rather. Button is for ePhone, skinny, but with the command number, with the combination of those two, we create a VoIP dial peer. Again, these dial peers, and in the case of skinny, eFXS voice ports, don't show up in normal running config. If we do a show run, it doesn't show up. Even if we do a show running config all, it doesn't show up. We can see these dial peers if we do things like show voice register dial peers, or even show voice register pool. The show voice register dial peer will actually show us, and we'll take a look at it again today, just briefly. Again, we covered this in depth in the last module, but just as a bit of a refresher before we talk about digit manipulation and where it occurs. The show voice register dial peer will just show us the dial peers only for our SIP phones, and then the show voice register pool and then the number of the index will actually show us more information about each pool and essentially phone, possibly multiple phones, we mentioned if we're doing SRST, and then also the dial peer or possibly dial peers that are created from the voice register pool. Also, to see our skinny dial peers and voice ports, we can do a show telephony service voice port to see the virtual eFXS voice ports, and we can do a show telephony service dial peers to see the dial peers that have been created from the ePhones and ePhone DNs. So they do exist, and they are the basis of really not only understanding, but the basis of the CME operating as a normal iOS gateway. So if you've ever done anything with an iOS gateway, even something as, I don't want to belittle it, but something as basic, something as starting out or rudimentary as just toll bypass with an iOS router. You don't have Call Manager, the big one. You don't have CME or UC500 or anything else. All you have is two iOS ISR router gateways, maybe connected to PBXs doing voice over IP or even voice over frame or voice over ATM. It's where a lot of people start. It's where I started back in '98, just doing the basics. If you understand the dial peers from there, and you understand something that we've covered in the past, but we'll definitely mention again, that there are always two call legs to every call, to every gateway. I should not say to every call, but to every iOS gateway, then you know that there are always an inbound and always an outbound dial peer that are chosen. Now, many times I see people that have, in consulting or whatever other practices, have failed to create inbound dial peers. Maybe they didn't know they existed or that they were necessary. And many times things still work okay. There are certainly probably nuances or situations that are run into where things don't work as perfectly as they could or should. But for the most part, things work somewhat okay. Maybe some unexpected behavior. And you say, well, if I didn't create an inbound dial peer, then it doesn't exist, right? Well, if you don't create one, then dial peer 0 is typically chosen. The default supports any codec, but we can't force anything. We can't really negotiate per se. It just kind of lets things happen. that is enabled. We can't do anything with applications, TCL or VXML service applications. Faxing doesn't work. There's a lot of things that really just don't work well, and you should never, ever leave an inbound dial peer left to chance. So not created and just left to its own vices, because you will at some point have issues, especially as you get into more complex and advanced configurations. And of course, we have inbound dial peers for POTS legs, typically from the PSTN, and then also inbound from VoIP, typically from a trunk or a link signaling, maybe back to CUCM or whatnot. When we get into CME, we again remember from last module, and just as a refresher, that if we're calling in from a SIP phone, we're coming inbound to the router on a VoIP dial peer. And if we're calling outbound to another SIP phone, we're leaving through a VoIP dial peer. This is what's known as IP to IP gateway, or CUBE, the Cisco Unified Border Element. And we do have to have, at a minimum, allow connections SIP to SIP enabled under voice service VoIP. Also, if we're coming in through SIP and leaving to a skinny phone, which is what we're about to take a look at, actually this one I believe is inbound from the PSTN, then we're coming in through VoIP and leaving through a POTS dial peer and then through a POTS port. If we're calling skinny phone to skinny phone, we're coming in through a POTS port, then in through a POTS dial peer, then out through a POTS dial peer, and out through a POTS port. And again, we looked at all of this in the last module. So if I just went too fast, as a bit of a refresher, please take a look back at that previous module. So now we want to look at digit manipulation. Where can we affect the calling, called, and even redirect called, or sometimes redirect target of our numbers? Okay. We typically, we almost always, if not always, have a calling, also referred to as ANI or ANI, and we always have a called, or sometimes I'll say called just to enunciate that, or DNIS, or dialed number identification service. I'll typically refer to it as DNIS or called. Sometimes, if the call was redirected or transferred, we may have an RDNIS, or redirected or forwarded number, also known as redirect called in voice translation rules. And Then sometimes we have a redirect target, which is as we are redirecting, who are we redirecting to? When we redirect a number, let's say a call has come to us, I'm at extension, I don't know, 3001, and I'm redirecting to voicemail, then I am the redirecting number. 3001 is the redirecting number. The redirecting target, while it's still at my location at 3001 getting ready to redirect, that would be voicemail would be the redirect target. I would be the redirect called. Okay? So those are the four things that we can change in. Typically, we're doing digit manipulation on the called number. But insofar as when we talk about voice translation rules, the four things we can manipulate or change are calling, called, redirect called, and redirect target. Okay, so let's take a look. We've got our CME or iOS gateway router here, and we see a call comes in from the PSTN. So if it's coming in from the PSTN, and let's say we have a PRI, then the first place it hits, and I apologize for the small text here, needed it to fit everything in. The first place it hits is our physical voice port. So here we have an E1 voice port 000, so from the numbering and everything we've talked about in the past, we know this is network module 0, also known as slot or unit 0, which is also the motherboard of the ISR router. Then we have /0, so subunit 0. So this would be the first, canonically speaking, the first slot or VWIC slot in the router. And then we have the third /0, which is the actual port. We might have a 2-port E1 card, so there might be /0 and /1 counting canonically. And then :15, our D channel for our E1. Kind of gives that away. If it was a :23, we know it would be a T1. Here on the voice port, we do have the ability to do possible manipulation. Typically, we would use a voice translation rule. Optionally, we could use a translation rule, which is really was around before voice translation rules. And as we mentioned, we haven't gotten into them too much in the past, and we won't because there's really no need to. If you know voice translation rules, you can do everything you need, and translation rules, not the voice translation rules, but just translation rules, are a much more limited subset of the functionality of voice translation rules. So there's really no reason to use them. There's nothing that they can give us that voice translation rules cannot. There are a lot of things that voice translation rules can give us, which we put into voice translation profiles, as you see us calling a translation profile here. There's a lot of things that voice translation rules can give us that translation rules cannot. So we've put in a voice translation rule, and we don't see the rule yet. We'll see it in our configurations, examples, and demos that we're going to go over today. But suffice it to say, this is on the translation profile. It's telling it to translate called, so DNIS. And here we're specifying the direction. And from the name, we could surmise that we're taking 10-digit inbound DNIS down to 4-digit. Okay, so the next place is it hits the inbound POTS dial peer, and notice we don't have a port here. We could have a port, and if we wanted to be more specific about where it is we want to do translations from, or specific about what it is we want to match, maybe we've got 10 PRIs and we only want to match calls from certain places, then we could have port here. But first we have incoming called number. And actually, let's just take a real brief moment and pause and talk about dial peers in terms of inbound matching. There are 4 criteria that can be matched in this order for inbound calls into a router. And this is for inbound calls where the type of the dial peer is VoIP, or where the type of the dial peer is POTS and it's a PRI or BRI. So something with a D channel, something with layer 3 intelligence. If it's CAS, FXS, or FXO, So again, even T1, E1 CAS, channel-associated signaling like T1 E&M wink start or fast start or E1 R2 or some form of CAS like that, FXO or FXS, we don't have this digit matching inbound order. It's simply that any of them can match in any order. But if it is POTS, PRI or BRI, or a dial peer of type VoIP, then for inbound matching, we first look to see if there is an incoming called number command on the dial peer. If there is and it matches, that is what will be chosen, period. Won't even look at port if we happen to have port on here. Secondly, if inbound called number, or incoming called number, sorry, is either not present or on all the dial peers it is present, doesn't result in a match, then we look at destination pattern. Now, let me back up and say incoming called number, as the name seems to imply, does match DNIS, or called number, on the inbound. The second matching, if incoming called number didn't match, is destination pattern, as I just said. And this one is a little bit tricky because the name sounds like it's called number, like DNIS. And it does match DNIS, or called number, on an outbound dial peer when the router's already selected an inbound dial peer when the calls come in, and now it's trying to select an outbound dial peer. It looks at destination pattern and it matches that against the DNIS, or called number. When it's trying to first, before it can ever match an outbound dial peer, when the router's trying to match an inbound dial peer, destination pattern does not go and try to match DNIS, or called. Instead, it matches the opposite. It matches ANI, or calling number. So on an inbound fashion, destination pattern matches ANI, or calling number. Then, if destination pattern can't be found as a match, then we look at answer address. Answer address also matches ANI. Believe it or not, sounds like it might be DNIS, the address that's answering, but it is matching ANI, calling. And then, if none of those three can be found or matched, then as a last resort, we match port. So the fourth option is port if it's configured. And then the fifth would be basically match dial peer 0, match the default dial peer. Okay, so on our inbound POTS dial peer, we have the ability, if we should so choose, to do a voice translation rule matching. This could be, again, doing further translation after translating it on the voice port. This is typically not the desired behavior, but we could do it. And just to be sure that we understand, certainly as a big difference from when we talked, and we're not going to go over that as a refresher, but when we talked about CUCM and we talked about route pattern, route list, and route pattern, route list details, and gateway calling party transformation patterns, we mentioned that all three of those were taken into account at once. And the digit manipulation did not happen immediately, but it was tentative, and it waited to see if there was something further on down the line to usurp it or trump it. Well, with what we're doing here in iOS, anything that goes and says do digit manipulation, so for instance, if there was a translation profile incoming applied to the voice port, that takes place immediately. And what the inbound dial peer sees is a result of whatever happened at the inbound voice port voice translation. So if we wanted to do further digit manipulation here, it would be, we would have to match a pattern and then translate it based on whatever was the result of happening at the inbound voice port. So after we have the option of doing inbound digit manipulation at the inbound dial peer, then we go to something that a lot of people have had confusion or misunderstanding with for a long time, which is number expansion. Number expansion is configured globally. It is not applied in any particular place other than you configure it globally and it's applied globally. So people say, well, then it's just kind of ethereal, it's kind of mystical, who knows when it takes effect, it could match anything, and not implemented properly or thoughtfully, it can cause problems, but implemented with care and thought, it can be quite powerful. We talked about it in Module 8 for gatekeepers, and here's an example. Doesn't really pertain to a call coming in from the PSTN, but here's an example of where it's great to use, which is for gatekeepers and specifically for stripping TEC prefixes for inbound calls, where the originating gateway sent a TEC prefix or prefixed a TEC prefix to the DNIS, and we, the terminating gateway, are terminating the call and are stripping that TEC prefix so that we can reach the ultimate destination. So here we've got an example, num-expansion, 1 hash, asterisk, space, asterisk. So 1 hash was actually the DNIS TEC prefix. Asterisk is the wildcard that represents any number of variable trailing digits, and we simply translate that from 1 hash and any number of digits to just the same any number of digits. So we strip off the 1 hash effectively. And we could add a prefix to the end. You know, if we were trying to do international tail-end hop-off, we could maybe match 1 hash asterisk and prefix 000 or whatever we needed to match an outbound dial peer. But the point is that number expansion happens after the inbound dial peer, regardless whether it's POTS or VoIP, but before the outbound dial peer. So here we have an outbound dial peer, and we can see this is dial peer 20,002, destination pattern 3001. So this is the second ePhone DN, essentially, to be created, or ePhone to be created. And the ePhone DN was number 3001. Doesn't have to match the 20,001. Can be anywhere, of course. And we could apply a translation profile here, but we would need to keep in mind, so in other words, we can apply a translation profile on an ePhone DN, and this will, in turn, place that onto an actual POTS dial peer. If we place a translation profile on an ePhone DN, we need to keep in mind which direction we want to place it. Is it going to be a translation profile for incoming or outgoing? You might say, well, wait a minute, an ePhone DN, so when is it incoming and when is it outgoing? The call's always going to the ePhone DN, right? Well, if the ePhone DN, number 3001, is the called number, or DNIS, then it is outgoing to that DN, yes. But if we wanted to, let's say, translate the calling number, every time 3001 picked up the phone and went to call someone else, 3001 is coming in on the inbound dial peer 20,002. And so we would, or we could look at it and say our second ePhone DN applied to whatever ePhone. So we would look at and apply a translation profile incoming, and then whatever the name was, to ePhone DN2. And what this would do is, and maybe that translation profile would be translating calling, maybe from 4 digits up to, I don't know, 8 digits or something relevant to whatever our application needed to be. And every time that phone picked up the phone to place a call in, every single call would be translated from calling digits of 4 up to 8. Now that might not be the desired effect. It might only be that we wish for calls out to the PSTN and out to certain numbers that their calling number be translated. And in fact, that's exactly the application and demonstration that we're going to look at today. But I'm just giving you an example of what we could do. And then finally, we've got the actual voice port. Now, when it comes to an ePhone or a skinny phone, we really can't apply a outbound translation or inbound translation to both the dial peer, POTS, and to the voice port. But again, if this were going out to the PSTN, we certainly could. We could have one outbound on the dial peer and yet another outbound on the port. So these are the places that we can do digit manipulation. Also, of course, on dial peers, typically almost exclusively in an outbound direction and almost exclusively as a POTS dial peer. We can do things such as forward digits, prefix. The default to any POTS dial peer is something called digit strip, which automatically strips any digits that were explicitly matched by the destination pattern. So we can change that default to no digit strip. So no digit strip or digit strip, prefix a number, forward digits all, forward digits 3, forward digits 12. Those are all other forms of outbound POTS dial peer digit manipulations. Another form of outbound VoIP dial peer manipulation would be, as we mentioned, tech prefix. Okay, so there are other different types of digit manipulation that we can do outside of voice translation rules, and then also outside of number expansion, which we said always occurs after the inbound but before the outbound dial peer. Okay, and then the call alerts at the phone. So now let's move into the theory of, and we're just going to cover, as we do in every deep dive, some of the more complex topics in terms of theory and concept in slides, and if people have any questions beyond the slides possibly, or maybe even likely, just depends on the module, how much we have. We can whiteboard certainly all of these things as well. We cover these first, and then we move into the actual demonstration and configuration, debugging, varying the configuration, testing, breaking, all of those aspects. So let's look at class of restriction, also known as CoR, in CME. And really this is in, again, iOS in general. Almost everything that pertains to CME, either Skinny or SIP, that is not configured under telephony service, the main Skinny server, or under ePhone or ePhone DN, or under the voice register global, the main SIP server, or voice register pool and voice register DN. Anything that's not configured under those main headings and just configured globally, obviously, maybe not obviously, but hopefully, applies to all of pretty much any iOS router, whether it's a router being used for toll bypass or an H323 gateway or SIP trunk SIP gateway to CUCM or even Cube. Okay, but we do have class of restriction in iOS in general, and the idea or the analogy that we would like to use for class of restriction is that of key rings with keys and doors with locks. Okay, so we're going to have really 4 entities here. Key rings and doors are the 2 overarching ones, and then on those key rings we have keys, typically multiple keys, but sometimes only one, and on the doors we have locks. And I'm going to advocate that you only ever put, at least for the most part, for your general configuration, certainly for the CCIE lab where you want to keep it as simple as possible. Don't add any confusion that they don't ask you about, because they'll add enough. You don't need to help them. But I'll advocate that you only ever add 1 lock per door. Okay, this isn't Detroit or you know, Compton or some of the more sketchy parts of the you know, cities where we have to have 15 locks on our doors, something like that. Okay, and in fact we're going to talk about an instance where maybe we don't even have locks on our doors, maybe we don't even have doors, just because the neighborhood's so safe, and what that means to class of restriction. But to begin with, you can see here that we've got a dial peer. Get my pointer out. A dial peer for voice to POTS. The destination pattern begins with a 0, secondary dial tone, typically common in most of Europe outside of the UK, and essentially 7 digits. A local number in our example here is going to be in the Netherlands. So, and of course we could probably dial a 0 area code as well, but we're just going to use it to differentiate from national numbers. So we've got a local dial in Amsterdam in the Netherlands. And on this POTS dial peer, we've got a door. We see it called CoR list outgoing because we're going to be leaving through this door, but the door is named local. So door-local, and a member of this door, or a lock on this door, is something called LOK local. And LOK stands for lock or key. Okay? And we're always going to name things lock or key, or you could name them lock key, however you want to call it. That's intuitive and, helps you remember. But the idea is that anytime we go to a locksmith and we have a lock built for us, they always give us a corresponding key or set of keys. So anytime we have a lock built, we also have a corresponding key. And in iOS, the lock and the key are the same thing. Now the door and the key ring that we put the lock or key and key or lock respectively on, the door and the key ring are not the same things. But the actual lock key or key, that is the same thing. It's a lock when it's on a door, and it's a key when it's placed on a key ring. Okay? So hopefully this analogy can keep everything straight. CoR has been a source of confusion for many of my students over the past 5 years, so try to keep it simple. And I can't claim credit for this analogy. It's one that a Cisco Pressbook had coined quite some time ago. Okay, so here we have the member or the lock of lock or key local on door local. Then we've got a national or long distance dial peer, POTS dial peer going out to the PRI, to the PSTN. And we've got a door named door national and a locker key named LOK locker key national. Okay, so we put the national lock on the national door, the local lock on the local door. Makes sense. Then we've got a key ring, and the key ring is, we see we're placing it either on our ePhone DN for skinny phones or voice register pool for SIP phones. Okay, as we mentioned in the last deep dive, some things in skinny and SIP phones are placed in kind of the opposite or unexpected places for SIP phones. Especially if you've worked with CME with skinny phones in the past to any degree, you might be used to putting things on the DN. So you've got an ePhone and an ePhone DN. You place things on a DN. Like we mentioned description last time, here we're talking about CoR list. But on the actual SIP phone, instead of doing it on the voice register DN, we actually do it on the phone itself, on the voice register pool. And you might say, well, then does that mean that we can't have different class of restrictions for different DNs on SIP phones? And the answer is no, it doesn't mean that, and we'll actually take a look specifically at that in a bit when we get to our demos. So either on the ePhone DN or the voice register pool, we place the key ring, and this key ring is called local, and we name it appropriately or intuitively so that it would seem to indicate, and in this case it does, that we've got the key of local, the lock or key local. In this case, it's a key. Okay, so a call is placed to 0, 703, 7373, 0 being secondary dial tone or outside trunk seizure. Okay, first, and very important that we understand this concept before class of restriction is ever taken into account, just like in the very same way before voice translation rules or any digit manipulation on an outbound dial peer is ever taken into account, or for that matter, anything on the outbound dial peer is ever taken into account, class of restriction or otherwise, the very first thing we do is we choose an outgoing dial peer based on a matching pattern. It's for that reason that you might say, if I do a debug VoIP dial peer, Mark, and by the way, that wasn't the command, debug VoIP dial peer, Mark, that was you asking me. Mark, if I did a debug VoIP dial peer and I have a class of restriction that should not allow me to dial, let's say, dial peer voice 3, why do I see 3 being matched? Well, it would be matched if the number you dialed, the called number, matched the destination pattern. And debug VoIP dial peer will not show you anything in relation to class of restriction mapping or allow or disallow. So the dial peer, the point is the dial peer is always matched first. In this case, we're matching the POTS dial peer because our second digit is not 0. The POTS dial peer 2. Then we check all the locks, and I do have to say all because we can have multiple locks on a door. You just have to have one key for every lock. It's just like coming home to your flat or apartment and you walk in, and if you have 3 locks on your door and they happen to have all been purchased at different times and so they have different keys, you didn't go back to the locksmith and have them rekeyed to the same key, then you have to have 3 separate keys for the 3 separate locks. Okay, this is a little bit confusing in the configuration, and it's why I highly encourage you and advocate only putting 1 lock per door. But again, we check all the locks of the outgoing door CoR list against the 1 or all of the keys of the incoming keyring CoR list. And if the incoming keyring CoR list has the needed key or all of the needed keys, then the call will be completed. Another way to put this is that the inbound CoR list has to be a superset of or else equal to the members of the outgoing CoR list. That's the technical way of saying it. The inbound CoR list has to have members that are a superset of, in other words, all of the ones that are on the outbound CoR list and more, or equal to. In this case, we have equal to. We have 1 key and we have 1 lock, 1 inbound member and 1 outbound member, and they are equal to the outbound CoR list. Then the call will be completed. Okay, any questions on this one? Let's take a look at another example. Here we've got an inbound call to 0010-704-7444. And so we first, again, match the dial peer. The dial peer is chosen. Now the CoR is checked. We have the key for lock key local, but the door has the lock key national, and we don't have any more keys. So the incoming key ring does not have the needed key, and so the call will be rejected. All right, that seems hopefully fairly simple to add on to what we just went over. Now here's the exception. Now we've got a call to 0010-704-7444, and we can see that either our inbound ePhone DN or inbound voice register pool, depending on whether we've picked up our Skinny or SIP phone respectively, and placed a call in through the CME out to the PSTN, to the national number. Again, first the dial peer is matched, but then we see that we try to check the locks on the outbound door against the keys on the inbound key ring. However, there's no keys. In fact, there's no key ring. And believe it or not, the call will be completed. So here's the exception to the rule that we just went over. If there is either one of the two, Obviously, if both of these exceptions are true, then that would just be no configuration at all. So we know that things work with no CoR configuration. But if there is either no key ring on the inbound dial peer, and therefore no keys, or no door on the outbound dial peer, whichever one is chosen, and therefore no locks, then the call will be completed. So here's the way to think of it in the analogy that we went over. Here's the way to think of this, or these two exceptions. If I come to an opening in a room that connects rooms, I kind of come to there's a wall, but there's an opening, but there's no door. It's just an opening. Well, if there's no door, then there's obviously no lock, so it doesn't matter if I have a key ring full of keys. I don't need them to unlock something that's not there. There's no lock, there's no door. That makes sense. The one that doesn't necessarily make any sense is if I don't have my key ring. Let's say I drive into my office, or I take the tube or whatever, commute into my office, pedal in, run, whatever you want to do, and you get there and you realize I left my house without my key ring. So I don't have any keys because I don't have my key ring on me. And by the way, you can't have a key ring with no keys. In other words, you can't have, technically speaking, a CoR list without any members. So because you can't have a CoR list without any members, you can't apply a CoR list that has no members. So if you have a CoR list, you have members. If you have a CoR list, you have a key ring. Therefore, you have keys. But we're saying we forgot our key ring. When you get to your office building, and I know this is a big no-no, especially if you have like the key card entry, Cisco buildings, you're never supposed to allow someone to be badged in behind you. And that actually, especially if you're working late, if you don't badge in and you work past a certain time, it won't let you out of the building because you have to badge out after a certain time. And if it didn't ever see you come in, then how could you be leaving? So, but anyway, the point is that assuming that we're kind of violating company policy or building policy or whatever, if you forgot your key ring, then you become the world's best social engineering hacker. And you can pretty much convince the cleaning lady or whomever that you just need access to this one room just real quick. And the bottom line is, if you don't have your key ring, you can convince him or her that you need access to every room. Okay? So if you forgot your key ring, you have unfettered, 100% uninhibited access to all outbound dial peers. Okay, so those are the two exceptions. So useful show commands for today. Some that we mentioned in last module, 15, such as show call active voice compact, show call active voice, not compact, but pipe to include peer, or even peer ID, but peer will give us everything peer ID will, plus a little bit more. Debug CCSIP messages, typically. Sometimes we'll debug other things. Debug VoIP Xcode MSP, so debug transcoders and the media signal processor, useful for debugging transcoding with Cube, which would essentially be any time a SIP phone is placing a call to either another SIP phone or out to a SIP or H323 trunk back to another call manager express, what have you. We're going to use this one a little bit today, debug voice DSP API, so the digital signal processor API, application programming interface, for both in and out states. This is useful for seeing everything that happens with both any hardware DSPs, but also any virtual DSPs. So ePhone DN DSP for an eFXS, or electronic FXS port, also known as the skinny phones. We talked about that in Module 15 and how they are created. Show DSP farm message statistics, show DSP farm units, and show DSP farm session summary is really useful for seeing an overview of both the idle and active hardware DSPs, not the electronic virtual ones, just the hardware, and their current state, codec, IP address, etc.